Hi guys, welcome to Algebra Online. We are in section 212 and today we are going to look at slope. We're going to look at the change in y, the change in x of an equation of a line and when we graph it. So let's talk about our learning target for today. I can discover that slope is the change in y divided by the change in x. And then you're going to be able to describe slope in lots of different ways today. But first we're going to talk about what is a function. Now remember that a function is an equation. So let's write that down. It is an equation. For every input, there is exactly one output. Output's supposed to be one word. Now, it's a working machine, right? And that's what we had been previously studying. And we're going to continue studying functions and their importance in algebra. All right, so hopefully you have you can take some time to write this down or print out the note sheet for today. And let's take a look. We're going to write the equation that represents this table. So whenever you're given a table, I want you guys to look at the growth, right? So let's see how much this is growing by. This is like habit. I want you to do this every time you see a table. And if you notice, they're all increasing by 1. Cool. Now the figure number is our x value, and then the number of tiles or squares is our y value. So what is happening to the y's? What are they increasing by each time? Looks like each time they are increasing by 5. Awesome. Okay, so if we know that this is increasing by 5 over 1, or increasing by 5 each time, and our zero figure, right, our zero figure is 2, then we can write this equation to say that y equals 5x plus 2, right? And I want to talk about when we have a slope-intercept form of y equals the mx plus b, that the m represents, right? The m represents the change in y over the change in x. So the change in y is 5. It's 5. It's changing each time over 1. And 5 divided by 1 is just 5. Okay, so is this a function? For every input do we have one output? Yes. So yes, it is a function, which means we can now write this equation in function notation. Notation is like a fancy way to say how we write functions. So if we know it's a function, then we're going to write it kind of like a cool way, and that is f of x. So f of x equals 5x plus 2. That just lets the person who's reading your work that knows, oh, okay, that's a function. All right, so let's take a look at the next slide. So we have 3 different graphs, and the first bullet point is we're going to determine what the zero figure is, and we're going to try to see what it's changing by, the line is changing by. So if you notice for the first graph, the zero figure is 3. And if that didn't come right away, let's go ahead and just make a table. So off to the side, we can create a table of our x and y values. And when x is 0, y is 3. When x is 1, and I'll go ahead and show this to you. When x is 0, right, y is 3. When our x is 1, our y is 7. All right, so our zero figure is 3, so zero figure is 3. And let's see how this line, right, is changing. So from 3 to 7, that is a plus 4. And 4 over 1 is 4. So we know that the slope is 4. And we can now write the equation. So the equation is y equals 4x plus 3. And it is a function, and so we can write it in function notation of f of x equals 4x plus 3. Okay, so let's go ahead and look at the next example. So with the next example here, our zero figure is 9, right there, right? When x is 0, y is 9. So we're going to write zero figure is 9. And then how is this line changing? How is it growing? And it is growing by 12 over 1, right? Rise over run. And that is 12, and that is our slope, which is our m in our equation. So now we can write that y equals 12x plus 9. And since it is a function, we can say that f of x equals 12x plus 9. Okay, cool. So let's try the last one. Actually, you should pause this and try this on your own. That's a great idea. Do that. Pause this, try it on your own. Press play when you are ready. Okay, so zero figure. The zero figure is 1, 2, 3. Zero figure I have is 3. And I have that this line is growing by 1 over 1, 1 over 1. And let me show that to you. From this point to this point, up 1 over 1, right? And I don't know if any of you made like a table. And if you did make a table, it would look maybe something like this where you put the x and the y. And let's take a look at this point right here. That is negative 1, 2, 3, negative 3, 0. And then I have negative 1, 2, negative 2, 1, and then negative 1, looks like it goes up 2. And so your pattern is increasing by 1 for the x's and the y's, which means that our slope is 1. That is supposed to be a 1. Let's pretend it's an ugly 1, but sorry. Okay, so now we can say that y equals 1x plus 3. You don't even have to write the 1. You could just say y equals x plus 3. And then for function notation, let's do that for function notation. So we would say y equals, oh, not y, f of x. I got in the groove. Okay, so f of x equals x plus 3. Whew. Oh, okay, so how is this line growing? How is it growing? So it is growing each time it's going up 27 and over 3. Now, obviously, it's not drawn to scale, right? And what that means is the 3 should be much like smaller than the 27. I know that, and that just means it's not drawn to scale. But it is still growing, rise over run. So let's go ahead and like write that down formally. So slope, right? Slope is how the line is growing. And when we talk about slope, we talk about rise over run, right? So how much is it rising and how much are we running? So it's rising up 27 and we're running over positive 3. And notice that there are positives in front of it because sometimes we're going to have negative slopes too. And 27 divided by 3 is 9. And so our slope is 9. And this line is growing 9 over 1, right? Good. All right. Now, if you can think about it as like tiles, though, right? As the figure is getting larger, right, by 1, it's growing by 9 tiles. All right. So slope's super cool and important. Okay, so we like to think of slope as triangles, right? Why not? Every time that we look at a slope, it's really looking at a slope triangle. And notice the triangles in front. Yeah, those really mean the change. So whenever you see that triangle, I want you to think change. The change in y over the change in x. So we can think of slope as rise over run. And it's also the same thing, the change in y over the change in x. Cool. All right. So the change in y is, it looks like it is, how many is this? 2 units here. So we have 2 over, and it's running how many? 1, 2, 3, 4, 2 over 4, and we would simplify that to be 1/2. So every time our, I'll take this, every time our x is increasing by 2, it's growing up by 1. See that? And you could actually, this is kind of cool too, which will lead us to the next and last slide. You could also draw another slope triangle here and another slope triangle here, right? Because that's a perfect point, that's a perfect point, that's a perfect point. Here's another one. This is a perfect point. So rise over run, perfect points. So let's take a look at the last slide for today, and we are comparing slope triangles. Now, guys, all three of these triangles, A, B, and C, they all should be the exact same slope triangle, right? Because this line did not change in steepness as it's getting larger, right? Like that's the slope. Like if you were to like go down the hill, the hill's not changing as you're sliding down. Why? Because this is a straight line. So all three of these should be the same slope, and so let's prove it. So the first thing we're gonna do is let's take a look at A. So triangle A, the rise of triangle A is 1, 2, 3, 4, 5, and 6, and it says plus 6 there, so 6 over. And then going across 1, 2, 3, and 4, and it says plus 4, so it's 6 over 4. Rise over run, we can simplify that fraction to say that it is 3 over 2. And essentially we can think about 3 over 2 as rise over run, and you could say 1.5, but in high school, we love improper fractions. We love them. And so we want to really keep our answer in improper fraction form, which is 3 over 2. Okay, so let's take a look at triangle B. So triangle B is rise, which is 1, 2, 3, over run 2. Hey, look at that, 3 over 2 and 3 over 2, they are the same as they should be, right? That's what we just talked about. Okay, so let's take a look at triangle C. So for triangle C is rise. Ooh, I don't know what that is. Let me erase. It says the change in Y is happening there. And so you're jumping up 1, 2, 3, 4, but notice that's not a perfect point. Okay, let's highlight those perfect points again, right? So the best way I can describe a perfect point is where these two lines, anywhere they meet in this nice like T. And so if that's the case, this would be a perfect point, and then this one would be the next perfect point. Anything in between those two are not perfect points. Let's see. So then the next perfect point would be here. Then the next perfect point would be here. Then the next perfect point would be here. And this is the y, like the actual y. If you have it go all the way over, that is the 14. And so it's a little bit above that, which might be hard to see. So for C, we know it's some change, but we're not quite sure how much. We know it's at least 1, 2, 3, 4, 4 and a little bit. But let's go ahead and take a look at the run. And it is 3, 1, 2, 3. So we know that we have a 3 in the denominator, and now we need to figure out what the run is. Well, if it's truly the 1.5, which it is, right, that means that this has to be 4.5. So it went up 1, 2, 3, 4, and then that is a half. And how do we know that's a half? Well, because if we divide 4.5 divided by 3, we get 1.5. That last one was a little tricky, but I'm sure you guys did just well. All right, so I hope you guys enjoyed today's lesson, and I will see you next time. Bye.